Okay, page 101. So you guys are already good at writing your double replacement reactions. And last day we looked at things that dissociate in solution. Okay, and so what we're going to do is we're going to put those two ideas together, the double replacement reaction and the dissociation. So what we've got is here is a double replacement reaction, which if you recall, we combine our outside ions to get NaNO3, and we combine our inside ions to get AgCl. And that is what we call the formula equation. But what we know now is that if you have NaCl aqueous, what is that really? It's really Na plus aqueous separate from Cl minus aqueous. So those two are separate. All right? And if you look in the picture, the Na and the Cl are dissociated. Now, how about our AgNO3? Well, AgNO3 is also aqueous, so Ag plus and NO3 minus are dissociated because it is a soluble ionic compound. So they are separate. When we put them together, if you recall, the silver and the chloride, you can use your solubility to chart to predict that there will be a precipitate and that the sodium and nitrate ions will remain unprecipitated. Yes? So what we can do is we can write a version of the equation which is called the complete ionic equation. And all we're doing is instead of writing NaCl and showing them together, we take the Na and the Cl and we show them separately. Okay? So we have separated the Na from the Cl because in reality, if you look in the beaker, they're separate. We're going to do the same thing with the Ag and the NO3 because in reality, they are separated.
And with the charges?
Yes. So in this complete ionic equation, you must include states, excuse me, and charges. Now, when it comes to the products, yes.
Sorry, so this is a double replacement. This is literally double replacement. Should we do this for like neutralization and double replacement?
You sure can. We may not get around to that this year. We'll see. You know, we might throw it in next Wednesday or Thursday or something like that. Okay, but I don't think we'll get to it for the test. Okay. So all that's going to happen here is that in our products, you can see that the Na and the NO3 are still separate. So we still write them separate. Na plus, NO3 minus, separate. And the Cl, AgCl, that is our precipitate, which is the solid that forms in a double replacement reaction. And because this particular type of reaction includes all of the ions, we call it the complete ionic equation. Yeah? So it's because it's complete. It's got everything. Okay. Now, let's say we go to a baseball game. Yes? At the baseball game, there is the team that is playing the game. Yes? Participating in the game, as it were. And then there's the people who watch the game and don't participate in it. What do we call the people who are watching the game? Spectators. So if you look at this reaction, you have the participants in the reaction. You've got the chloride that ends up becoming part of the solid, and you've got the silver that ends up becoming part of the solid. Those are the participants in the game. And then you have the sodium, which stays as sodium and does nothing, and the nitrate, which stays there and really does nothing. They just watch the reaction happen. So we actually call those the spectator ions. The ions that do not actually participate in the reaction are called the spectator ions. So Na plus and NO3 minus start out separate and free floating. And they finish separate and free floating. So they did not participate in the reaction. And so what you can do is, if you have a complete ionic equation, you can go through it and say, I have an Na plus on the left, and I have an Na plus on the right of my reaction arrow. So I can actually cancel those out because they did not change. Okay? And then I can say, oh, my Cl started out aqueous, but now it's part of a solid, so it did change into something new. My silver started out as a separate ion, but now it's part of a solid, so it's something new. But the NO3 started out free floating and aqueous, and it finished free floating and aqueous, so I can cancel that out. So if you see something that is unchanged from one side to the other, those will be the spectator ions, and you can cancel them out, and that will get you this version of the equation here in blue. And you might notice that up here it says Cl minus plus Ag. I've reversed the order just because I'm a little bit like OCD that way, and I like my metal to come first. But you could have written it Cl minus aqueous plus Ag plus aqueous. AgCl solid. That reaction there is called the net ionic equation. Do I have that written anywhere here? Oh yeah, it is. That is our net ionic equation. So it takes out, oh my God, I'm spitting out my cough drop here. Let's throw that away. It's gross. Okay. So the Na plus and the NO3 minus are called spectator ions. So when you have an equation, you will probably start with the formula equation. Okay, in pink, you'll probably start with the formula equation. And then anything that is aqueous, you will separate it into its ions. Okay, so anything that's aqueous, split it up into its ions. And that will give you the complete ionic equation. Okay? And we can call the formula equation the FE, formula equation. We can call the complete ionic equation the CIE, complete ionic equation. And then to get from the complete ionic to the net ionic, you cancel out the spectator ions. Okay, so to get from the complete ionic to the net ionic, you cancel the spectator ions. Yes, you do. This one is balanced already. We'll take a look at some that need more balancing in a moment. Okay, yeah. All right, so that's basically what we've got there. And we're just going to do a bit of practice with it because, you okay? Okay. All right. So this just walks you through it a little bit more. It highlights the fact on the next page. It shows you, oh, look, here are our spectator ions. The Na and the NO3. And you can see they are exactly the same at the end as they were at the beginning. And this bit here just runs you through what we just talked about. How do you write a complete ionic equation, a CIE? You start with the formula equation. You separate the ions, but only for the aqueous substances. The solids stay together. And then to go from the CIE, the complete ionic equation, to the net ionic equation, you cancel the spectator ions. Okay? So we are going to try another one here, and I'm actually going to grab this and do it from scratch. Okay. It's all written for you, but should you want to get your own paper and do it on your own paper, you certainly could. Okay. Okay. Just like before, you're going to say, who are my ions here? And we have Fe, and we have NO3, we have K, and we have CO3. In order to predict the products correctly, we need to have the charges of those ions. We can look up NO3, it's -1. We can look up CO3 2-, it is, or CO3, it is 2-. K, we know, is in column number 1, it is positive. Okay. All done? Good stuff, just in there's great. And then we have to ask ourselves about iron. What is the charge of iron?
3.
It is 3 because we have 3 of the NO3 minuses, so we have a 3+. Okay. Now we're going to combine our outside ions. So we have Fe2CO3, 3, and then the K goes with the NO3. Now, in order to be able to write a complete ionic and net ionic, you have to tell me what the solubility of these things is. What is iron carbonate's solubility? You will want your blue sheet.
Oh, iron carbonate?
Iron 3 carbonate. You will want your blue sheet. If you do not have a blue sheet, I've got some extras.
Right.
Anyone need a blue sheet? There you go. Anyone else need a blue sheet? Over here, don't forget me. There you go. Anyone else need a blue sheet?
Wow. Sweet.
Last call, blue sheet. Okay. All right, so on your blue sheet, you will go and you will say iron carbonate. And you'll be like, okay, where's my iron carbonate? Carbonate is way down at the bottom. And unless it is an alkali ion or hydrogen or ammonium, everything else is low solubility. And so that means that iron 3 carbonate is a solid. KNO3, well, it's got both an alkali, and all alkali salts are soluble. It also has NO3 minus, and all nitrate salts are soluble, so that one absolutely has to be aqueous. What do we call this form of the equation? This way of writing the equation?
Formula.
This is called the formula equation, okay? This here is the formula equation.
But it's unbalanced right now.
Okay, and right now it is unbalanced. So let's balance this puppy. Remember, you probably want to balance your most complex compound, the things in it first. So we have 2s and a 3 here. That is our most complicated compound. So let's balance our irons. We have 2 iron here, so let's put a 2 here. We have 3 carbonate here, so let's put a 3 here. And that leaves just our Ks. We have 6 Ks, and we're going to put a 6 there. We also have 6 nitrate, which works out well because we also have 6 nitrate. Okay, I'm going to get rid of all my little arrows there so that we can follow along a little bit better. Okay, now we're going to split this apart into ions. You have to use both the coefficient and the subscript when you're looking at the number of ions. Use both the coefficient and subscript to find the number of ions. So what do I mean by that? Well, for iron, we have a coefficient of 2. There's no subscript, so that means that because this is aqueous, we want to split this apart, right? We're splitting it apart into its ions. We have 2 Fe ions. Okay? What have I forgotten here? I need the state and the charge. The state is aqueous. It will always be aqueous for the ions. And the charge, remember, we determined that it was iron 3+. Now for nitrate, remember we have to look at both the coefficient and the subscript. So we have 2 times 3 is 6 nitrate, 6 NO3 minus. Don't forget your charge and your state. Okay, so we split that up. We've got our irons and we've got our nitrates. Our next substance is aqueous. Do we split it apart? Yes, we do. When it's aqueous, we split it. Remember, both the coefficient and the subscript. 3 times 2 gives us 6 Ks. But not just 6K, 6K.
1 plus.
1 plus, and aqueous. Don't get messed up here. How many carbonates do we have? Do we have 3 or do we have 9? We have 3, okay? 3, because this 3, remember, is part of CO3. If we wanted to have more of it, we would have to put it in brackets. If we actually had 3 of them, it would be like that, but that's not what we have. So we have 3 CO3s. And the charge of that, don't forget the charge, is 2 minus, and that is aqueous. Brinkelhoff does not come into effect here because Brinkelhoff is for neutral, not ions. Yes? Okay, so no Brinkelhoff in here because ions don't Brinkelhoff. Okay? Ions do not Brinkelhoff. Okay? Only neutral elements. So the moment you see a charge on there, you go, no Brinkelhoff. No. All right, now we got our reaction arrow. And I have to say, complete ionic equations are a pain because they are so freaking long, right? So very often, if I'm giving you room to work, I will give you a second line to work on. So maybe you can put your products on the second line. I'm going to do it all in one line here just so you can see it. You've got it in your book there. Okay, so we have now, there's no coefficient, but we do have a subscript. However, what state is that?
That's solid.
That is a solid. So what do we do with it? Leave it alone. Just let it be. It just stays together. Solids stay together. Okay, so we still just have Fe2CO3, 3, solid. And our next one, we are back to aqueous, so we have to split it apart. We have 6 Ks, so 6K plus, aqueous, plus, how many NO3s? 6. 6 NO3s. 6 NO3 aqueous. What have I forgotten? The charge. Okay? Make sure you got that charge on there. And what do we call this equation? This big, long, crazy thing. So this one up here was the formula equation, or this one here. Sorry. That was the formula equation. What do we call this one? This is the complete ionic equation, or the CIE. Now, if you want to turn that into, what's the next one? After the complete ionic equation comes the net ionic equation. Who do you have to look for to find the net ionic equation? Look for spectator ions. Tell your partner, who are the spectator ions in this reaction? I'm going to try and make it a little bit bigger. I'm sorry that it's not, I can't make it bigger yet. Who are the spectator ions in that equation? And usually if you're having trouble finding them, you can be like, oh, okay, you know what? I'm going to look at my products because definitely they're going to be there in the products. So I got some K pluses, and on the other side, I've got some K pluses. I got some NO3 minuses, and I got some NO3 minuses. So one of the things you might be asked to do is to identify the spectator ions. And I want to say, I do not want you to do this. Not 6NO3 plus 6K plus. The reason I don't want that, there's two things I don't want there. I don't want you to say 6, because that implies that there are only 6 nitrates which are spectators, whereas you have moles and moles and moles of these things, right? You have millions, billions, trillions of these ions. Yes? So you don't want to say, oh, just 6 of them are spectators. So you just want to say NO3. NO3 minus. I also don't want you to use a plus, because that implies that they are reacting. Because that's how we write things that react, right? Is by putting a plus between them. So you can put a comma. You can put an and. You can write and. Okay, any of those are fine. So not this. Yes. This. Nope. You don't have to. If you want to, you can, but you don't have to. Because if they're spectator ions, by definition, they have to be aqueous. Okay? Once you've identified your spectator ions, what do you do with them to get to the net ionic equation?
Cancel.
You cancel! Okay, so we go around and we're like, cancel, cancel, cancel. Okay, so we cancel this, we cancel that, we cancel that, we cancel that. And we are left with 2 Fe3 plus aqueous plus 3 CO3 2 minus aqueous goes to Fe2 CO3 3 solid. Whenever you write your net ionic equation, the only states you should have in the products is solid. Okay, and that is our net ionic equation. Okay? So it's really not that much different from what you've been doing before. Just remember, when you're separating them, you need to use both the coefficient and the subscript to figure out the number. All right? Now let's just take a look at, so this works you through the whole thing, right? Like it steps you through every step of the way. Oh, look, we have 2 Fe's. Okay, there's our complete ionic equation. There's our net ionic equation. Now, I have a trick for you. Let's say I gave you these reactants. Fe, NO33, plus aqueous, plus K2, CO3, aqueous. And what if my only question was, write the net ionic equation? Okay? For you guys, you won't get that this much this year, but next year in grade 12, this is a key skill, is being able to write the net ionic equation. Okay? So, if you're asked to just write the net ionic equation, what you can do as a shortcut, and if you don't get the shortcut this year, don't worry about it. You don't have to ever do it this year, but I'm putting it out there for you in case you like it. You're going to say, I combine my outside ions and I get a low solubility compound. I combine my inside ions, and without even writing it down, I know I get something that is soluble, right? So what I can say is I can say that my solid product is Fe2CO3, 3, and that's a solid. To write the net ionic equation, all I have to do is say, what ions did I need to make Fe2CO3, 3? I needed 2 irons, and I needed 3 carbonates. And that's it. There's your net ionic equation. Okay, so that's like a little cheat if you are asked to write the net ionic equation and you don't want to go through the whole thing. But on your test coming up on Monday, you will be asked to write the complete ionic equation and the net ionic equation and identify the spectator ions. Okay? So you don't have to worry about that shortcut. Special case, 2 precipitates. So here we have copper sulfate and strontium hydroxide. When we combine our copper with our hydroxide, copper hydroxide is low solubility. The strontium gets together with the SO4, and that is also low solubility. So we have 2 precipitates. Precipitate and precipitate. Who are the spectator ions?
We are.
We are. That's it. There is nothing. We are looking at the reaction, but there's no chemicals in the reaction who are not reacting. So when you write your complete ionic equation, it will be the same as the net ionic equation because there will be no spectators to cancel out. No spectator ions. Okay, so we can see if we write it, the Cu and the SO4 are split apart, CuSO4. The Sr and the 2OH are split apart, Sr, and we have 2 OHs. But our products are there, there's no spectators to do. And then finally, if we have no precipitate, what should we be doing? No reaction. So we say, no reaction. Well, actually, I shouldn't cross out the beaker. I should only cross out this because you don't really get anything as a product because there is no reaction. It just sits there. Okay? If you tried to write a complete ionic equation, you'd be like spectator, 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 spectator. Oh, oopsie. Yeah, nothing left. Okay? So,
In this test, if we get a question like this, will you require us to write it out and cancel it all out?
No. If you have 2 aqueous, you just say no reaction and you're done. Okay? So, what you can do now is no, we don't want to do 7.6b. What happened here? Where are the questions? You guys must have a page 105 and 106. Yes? I don't, but that's okay. You can do pages 105, 106. Yes. Yes.
They still like no, they don't. No,
Because they're like, I wasn't with anybody and now I'm still not with anybody.
Oh,
Yeah.
and it's kind of like a way to go with.
Yeah. Yes. Was there anyone who was away yesterday? Anyone who was away yesterday did not get the handouts? I will grab those for you. This one, I don't know why. But anyway, it is. And then another one as well. So we got this yesterday. This is something we have to do fast. Okay, so we practiced that yesterday, so. Okay, and. Small, right? Like a whole time. So we're gonna do what I'm tired. You can have, you want to come to the one side, right? Like I'm not going to have this like the positive side and slightly negative side. And if you
Why you put my life for work with the life for
then you have a bigger charge, and so that causes the force to be very stronger. So then I'll get other eye to this. Okay, before
I'd be like, I don't know.
yeah.
Do you want to go and make my house?
Okay, so I should just go and yeah. Metals on their own are neutral.
I just have a friend, yeah, like we just write the city like a friend. Yes. Yeah. Yeah. It makes me feel
And then you have one out that's right on one side.
I don't know. No, I made Ritz pepper pie, but like no, but like with the Ritz cook, you didn't break the pepper.
But water makes.
No, it made like pie on the peppers.
Solid half.
And it tastes really good.
I
didn't have apple pie. I gave it to my dad, and he didn't know this was made out of. He makes some great apple pie.
And
not really. Good. It was actually good. Okay, that's good.
yeah. First morning, not very many phones.
So you could, you finished your essay at least.
So it's not. Okay, so this one is folks. I'm not quite sure why. Yeah. I don't know why I didn't give like lots of space to this, but page 106. Get some separate paper. Okay. So get some separate paper and do pages 105, 106 on separate paper. Okay?
You're around the 6 weeks too, like, come on, buddy. No, but look, are these valves? These are valves, like the charge, the charges are fine.
Yes.
So you can
Yes. Yeah. No, I know.
Sure.
Folks, do the ones on 105 because we're doing double replacement. 106 is single replacement. Do 105. I know I didn't leave space for you. I'm going to see if I have a copy that has space on it, and if I do, I'll print it out for you.
Just 106 is